Hey guys, for those of you who don't know it, I'm Ethridge, the president of Console Classics, and the purpose of this video is we're going to show you how we go about building one of the adapters we use to read games. A lot of people have been asking us where are the new NES games. There are a few little complexities when reading NES cartridges, and I'm just going to open this up and show you real quick. This is the King of the Ring if anybody's curious. And what we've got here is one of the classic NES setups. I don't know if you can see that or not. But basically we've got two chips here. There's actually a third one. The program file, the actual game program itself, is on that chip. The graphics are actually on that chip, and then that's just RAM. The problem is that this edge connector doesn't have enough pins on it to be directly connected to all three of these chips. So what you actually have is you've got mapping circuitry where the program will be running along, the game will be running, and then it will actually do a write to this mapping circuitry and switch pages. I may do a little more to explain about that later on. Right now, the point I want you to take away from this is this edge connector is not directly wired to these chips. So we can't just jam it down in a reader and read all the data off of them. Like I said, this is a pretty standard setup. We got a PRG and a CHR, and that's the program and graphics. Another one that we're looking at, somebody sent us some Bomberman 2 years ago, and it's a little bit different of a setup. You've just got a PRG chip and then two RAM chips. Here you probably won't be able to see it on the video, but these are actually 32 pin ROMs, and this is a 28 pin ROM. That's another problem, is that the packages are not consistent from one game to another. What we're going to do to solve this whole edge connection problem is we're going to take a Super Nintendo game, and I'm not going to show you which one this is because this poor little guy's going to get zapped. We're going to pull all these chips off the board. Well, really primarily these two. These two chips actually are directly wired onto this edge connector. Alright, we're going to pull these chips off, and we're actually going to put a ZIF socket in place of one of these ROM chips. Alright, then what we're going to do is we're actually going to leave the other space empty for cross-wiring purposes. What we'll be able to do is mount the ZIF socket here. Any connections that aren't right we'll be able to break, and we'll just do that by taking a tiny little drill bit and cutting the circuits. Then we'll be able to wire them to the correct socket up here where this second chip is. Once that's done, what we'll be able to do is pull a chip off of one of these boards, drop it in the ZIF socket on this board, and then put this down in our Retrode, which, those of you who don't know what a Retrode is, it is a really nifty USB device that's just recently been developed. I don't think you can currently get them. The guy made like a micro batch of maybe a couple hundred, and they're sold out. We are replacing all of our reading equipment with the Retrode. There are several reasons. The main thing being that it's just USB standard. We can actually open it with a drive editor and directly get to the memory that's in the Retrode. Console Classics has also done a little bit of development for the Retrode. We built a TurboGrafx-16 adapter. The manufacturer of the Retrode, a guy named Matthias, actually did the software work for us, but we did the hardware work for the TurboGrafx-16 adapter, so people can use their Retrodes to read TurboGrafx-16 games, in part due to what Console Classics has done. What we're going to do is we're going to cut away, and we're going to go back to me actually removing some of this stuff from these boards, and we're going to show you how we do that, and then I'll show you how we're going to mount the ZIF socket in there and actually do some of the cross wiring. This video is probably going to be broken up over a couple of days. Either that, or we just pause the camera for me to change shirts and make it look like it's a couple of days. You guys can figure out which one we did. All right, so, guys, same shirt, same day. We're going to go ahead and start working on some of this. We will not get done today, but I want to go ahead and get a jump on it. Got a load of equipment here. I want to show you. We've got a rework station. This is basically a hot air gun. The tip that we've got in it right now is specifically for removing these dip type switches. Got a soldering gun, obviously, solder sucker, flathead screwdriver, and duckbill pliers. Alright, and the first thing we're going to do, we're going to remove these two chips, and then we're going to remove the battery to make sure we don't have voltage on the board at all. The other chips we can probably leave in place. If we get any noise, I'll remove them, but I don't want to do that unless I have to. There's always a chance when you're pulling these chips out, you can actually tear one of these lines. Normally, even if you did that with one of these, it wouldn't be a problem. But if there's no need to remove them, I'm not going to. So the first thing we do is turn this on. And very, very quickly, this end begins to blow out superheated air that is capable of melting solder. And that's exactly what we want to do. So we'll just start with one of the chips, and it doesn't matter which one. And we're going to just work back and forth until the solder begins to soften. And then I'll probably reach up there with the flathead screwdriver, kind of pry it under the chip, put a little pressure on it, and then continue to do this, and the chip should slowly slide out. Now this is going to take a while. We're not actually going to record me doing this. What we're going to do is we're going to pick back up once I've got the board cleaned up and am ready to put the ZIF socket in place. So that's about it for right now. Alright, what I've done is I've pulled the chips off and that battery off, and I've gone ahead and taken the ZIF socket. I've trimmed it to size. This was a 32-pin chip and a 40-pin ZIF socket. Some of you may be asking yourselves why I didn't just buy the right size socket. They were a lot more expensive, and so we just bought the 40s, trimmed them down to size. Probably tomorrow I'll actually solder that in place. It may just work without any cross wiring. The layouts are very, very close. It won't be where it would normally be in memory, but I'm going to have to open this with a drive editor anyway, and so what I'll probably be able to do is just grab the data and copy it where it shows up and then just use it. So we may not have to cross wire it. If we do, there's very little cross wiring that we have to do. Basically 2 pins we need to move, and we'll just see how it goes. So until we pick it back up. Different shirt, different day. I skipped a lot of tedious soldering. I didn't think you guys needed to learn how to solder from me. You can see we've hooked up 2 of these. For those of you in the know, this is because the Super Nintendo has what's called a low ROM and a high ROM system. And so I've made a board for each one. This is a low ROM, this is a high ROM. If you know what that means, then you know what I'm talking about. If you don't know what that means, you don't need to know what I'm talking about. Now, these are all just straight wired pin to pin. I haven't done any cross wiring at all, and the reason for that is that I decided we're probably going to use a software solution for descrambling the memory. Even if the wiring isn't quite what it should be, it's very, very close, and there are just a few memory addresses that are basically scrambled. And each NES chip, there's a lot of variation, and so if we make a hardware design, it may not work in every situation anyway. So with a software solution, what we're doing is we're taking the memory and descrambling it. If we know what to expect, we can do that no problem. If we run into a chip that doesn't match the current layout, we can just add software to handle that descrambling, or we can actually open it in a memory editor and descramble it by hand. And I'm going to show you some of that real quick. This is, you can't really see it now, I've got it all laid out, but that's Bomberman 2. And this is the main chip for Bomberman 2. So what we do is we're going to take, I'm actually going to take the high ROM reader, just drop the chip in there like that, alright, lock it in place, pop it in our Retrode, plug the Retrode in, and it'll actually pop up under my computer. Now, the Retrode is not expecting a NES game, so it's not going to know what to do with that at all. If you actually open it here, it thinks it's an Atari cartridge. It doesn't know. Eventually, Matthias is probably going to add his own Nintendo support to the Retrode, and when that happens, we won't need these adapters all anyway. For the moment, though, what we're going to do is we're actually going to open it in a drive editor, and I'm just showing you this for those of you who may be curious. We can actually open the drive and look at the raw memory there. Alright, and we can actually go down. I happen to know where the memory is. I mean, obviously I had to track all this stuff down and whatnot, and you've got to actually type in the right address to get where you're going. This is the game. And it's a little bit scrambled. The current config, it takes in 64K pages, and it's scrambled, but it's very easy to actually copy and paste out of here and de-scramble it. This is going to be nonsense to most of y'all, so I decided to show you something that was kind of cool instead. To make sure that this thing is wired up appropriately, we can actually take the game from which it came and drop the Super Nintendo ROM. This is the same ROM that I actually took off the board originally. Put it in our zip socket, put it back in the retro, and we're actually going to open ZS NES, which is the Super Nintendo emulator we use, and we're going to load. We're actually on the F drive, which is the retro, and you can see right there it knows the game name. We double click it, it'll take it a couple of seconds because it's actually reading it from the retro into RAM, and as you can see, it read the game. Like I said, I use that example to show you it is wired up correctly, it is working. It doesn't work perfectly for NES chips, but that's as far as I'm going to take it. When I start actually developing the software, we may do another video for those of you that are really interested in how the memory management works on things like this. Most people are going to be bored to tears with this stuff. The point is we're going to have new NES games up, and that's really what matters to you guys. And that's basically it for this video, just a quick breakdown on what it takes for us to do something like build new reading equipment in order to get NES games up for you guys. You know, we do this stuff for y'all, and we know y'all appreciate it. So, and we appreciate you guys too. And that's it.